All right, guys, so this is video 2 of our unit on quadratics. Okay, so let's title this Characteristic of Quadratics.
Did you finish reading today?
Okay.
I know, you just speak up, Zachary.
All right, so on the first video, we discussed that the standard form, the one that I was going to introduce you to first, was this one. Standard form of a quadratic. ax squared plus bx plus c equals 0. Okay, so let me give you an example. X squared plus 2x minus 3 equals 0. So what you want to do when you get a quadratic like that is you want to identify what value is the a, what value is the b, and what value is the c. Okay, because all of those numbers kind of play an important role on getting some important information about your quadratics. Okay, so that's the first thing we want to do. We want to identify what number was a, what number was b, and what number was c. Well, next to the x squared is your a, but in this case it's an imaginary 1. Next to your b, in the middle one, next to your x is your b, which is a 2. And finally, the last number is a negative 3. Okay, now what is so important about these little numbers? Let me show you what you can do with these numbers, okay? The first thing I want you to note is that the a is important because if it's a positive number, if it's a positive a, then that tells you, oh, I'm going to have a quadratic that opens upward. But if a is negative, it's going to tell you that your graph is going to look something like this, which means it opens downward. So that's what's important about the a. That's the information that the a gives you, okay? So by looking at my example, let me see if I can capture that here. Okay, so by looking at my a, I have a positive. So guess what? I am going to have this. I know that even though I haven't started graphing, I know my parabola is going to open upward, okay? That's how you use the a. That's why it's useful. Now, I'm going to skip how useful b is right now. I'm going to go to this one because this one's super easy, okay? Whenever you're given a standard form quadratic, whenever you see all the numbers, everything on the left and nothing on the right, that's standard form. Whenever you're given that kind, always go look at the c, because the c will always be your y-intercept. Okay, so the c is always your y-intercept. So here, this guy right there, that's your y-intercept. So I know that my y-intercept is 0, negative 3. Because remember that all y-intercepts have a 0 first and then the number. Okay, so the c is useful because it tells you, hey, I'm going to cross the y-axis at 0, negative 3. Okay? Now, how is this useful? Because these numbers can help you find the most important, one of the most important points on a parabola, which is your vertex. Okay? So here's how you do that. There's something called the Axis of Symmetry that I talked about in the previous video, right? So the Axis of Symmetry is the line, the vertical line, that cuts your parabola in half. Vertical line that cuts the parabola in half. And we said that because it's a vertical line, then it's always x equals something, right? Because it's a box, it's a vertical line. It's always going to be a line like that, okay? You see? It's going to be a vertical line that cuts it in half, right? So how do we find it? There's a little formula for it, okay? And it looks like this. X equals, so in order to find that number, you take the opposite of b divided by 2 times a. The opposite of b divided by 2 times a. Okay? So, the opposite of b, well, if b was a 2, the opposite would give me negative 2. 2 times a is 1, so 2 times 1 is 2. So negative 2 divided by 2, negative 1. So now I know that my axis of symmetry is x equals negative 1. This is your axis of symmetry. And not only is it your axis of symmetry, but it's also the x value of your vertex. So now I know like half of my vertex. Negative 1 something. Remember, the vertex is that little point, the highest or the lowest part of your parabola. You got half of it already. So then how do I find the other number so I can complete my vertex?
Okay.
Well, you plug it in.
That's the cow.
Plug in this x in to your equation and solve. So like I'm going to take my equation, x squared plus 2x minus 3, and I'm going to plug in a negative 1 everywhere I see an x. So it'll go here, it'll go here, so negative 1, negative 1. And then I just solve. Negative 1 squared means negative 1 times negative 1, that's positive 1. 2 times negative 1 is negative 2, and then I still have this negative 3. 1 minus 2 is negative 1, and negative 1 and another negative 3 make negative 4. So guess what? Now I know my vertex. Now I know my vertex. Okay, so I'm getting a picture of what my parabola looks like without even having to graph it. I know that it's going to open upward because A was positive. I know it's going to cross the y-axis at 0, negative 3. And I know that there's this line that cuts it perfectly in half at x equals negative 1, and that my vertex is 1, negative 4. Well, guess what? I can probably already graph it without having to get any more points. I think I can graph it. I can get like a good picture. Okay? Let me give you a good picture. And this is just a sketch. Just by this information. Let me give you a sketch. Okay, I'm going to go and plot negative 1, negative 4 for sure because that is the vertex. Hold on. There we go. Negative 1, negative 4. That's my vertex. And the y-intercept is 0, negative 3. Right there.
I like your glasses, Emily.
Thank you. These are not real, they're just for the blue light.
And then here it is. There's my axis of symmetry. X equals negative 1. So I know my graph is going to be like that because it opens upward, but I need another point here, right? Well, guess what? The axis of symmetry, remember, cuts it like perfectly in half. So if I have a point here, it's like one space away, right? So I can just jump one space away, and there's got to be another point there. So I know that it's going to look like this. So that's a good sketch, okay? You want to be more accurate because they're going to probably ask you about the x-intercepts, but at least you know that that's more or less what it looks like. All right? So how do we get more numbers? You make a table. All right, so let's put a little note. How do we get a more accurate graph? Well, you're going to create a table. Now, the question that students always have is, well, I don't know which numbers to like include in my table, right? Well, that's why it's important that you learn how to find the vertex. It's important to know how to find this and then to plug this in to find the y, and now you got your vertex. Because if you have your vertex, I always like to kind of put my vertex in like the middle, sort of. Not that it's always going to be in the middle on the table, but I like to put it that way because now I know, hey, well, if this is my vertex, I better include, you know, some numbers on this side, and I better include some numbers on this side. And then that would give you a good, accurate graph. Okay, so how do we get these? Okay, here's what you do. You can either do it by hand, and you can either take your equation, x squared plus 2x minus 3, and plug in these guys, solve, plug in this one, solve, right? Let's do one of them that way. If I plug in a negative 4 here, that's negative 4 times negative 4. That's 16. Then if I plug in the negative 4 here, 2 times negative 4 is negative 8. So now I have 16 minus 8, that's 8. Minus 3, that's a 5. I can do it that way. But listen, standard form, remember we said that it's either equal to 0 or a y. It means the same thing. Well, then this is perfect because that means that it's calculator ready. Instead of me having to plug in all my numbers, I could just plug it into my calculator. I think my batteries are running low. Yeah, let me see if I can get some. No, I can't step away. Okay, so I could put it in y equals. I could go x squared plus 2x minus 3. That's it. And then go second graph. I can go to the table and get all the numbers from there. Okay, I'll show you that on a later time, but I guess we can do these by hand. So negative 3, if I plug it in here, negative 3 times negative 3, that's a 9. 2 times negative 3 is going to be a negative 6. 9 minus 6 is 3. 3 minus 3, 0. Negative 2 squared is 4. 2 times negative 2 is negative 4. So 4 minus 4, gone. And I'm just left with a negative 3. And remember, this is your vertex. Remember what we learned on the first video? That your vertex starts separating repeating numbers. So I can just go like this. Oh, this is going to be negative 3. This is going to be 0. This is going to be 5. That's how it works on a parabola. Okay? So now let's draw our graph. I'm going to plot my points. Negative 4, 5. Negative 3, 0. Negative 2, negative 3. Negative 1, negative 4. 0, negative 3. 1, 0. And 2, 5. Okay. So why is it important to get a more accurate graph? Well, because they're going to ask you about the x-intercepts. On our sketch, we weren't so sure about them. Okay, so now we've got all the information that we need about everything they can ask you about the characteristics of a quadratic. So let's start with, which way did it open? Well, always look at your arrows. Are they pointing up or are they pointing down? Well, they're pointing up. So we say this is opening upward. Why? Because the A is positive. Anytime A is positive, you don't even need to look at the graph. As soon as A is positive, it's going to open upward. Okay? What was the axis of symmetry? The axis of symmetry, remember, it's that line. It goes through the vertex, and it cuts your parabola in half. So it's always going to be the x value of your vertex. It's going to be x equals negative 1. So x equals -1. And we found it a long time ago. We found it by using the formula negative b over 2a. And we found our axis of symmetry. Okay. So there's your axis of symmetry. What was the vertex? We found the vertex a long time ago also. We knew it was -1, -4. So this is the vertex right here. This right here is your axis of symmetry.
Okay, we're going to go into a doctor's
Then
activity.
I want to know, is this vertex a minimum or a maximum? So I'm going to put a little down arrow. Is this vertex a minimum?
Coach Sanchez, why will we escape from Cat in the Hat? He's so fun.
Or a maximum, first of all? Minimum or maximum? Well, what is this point? Is this point the lowest part of your graph or is it the highest? And I like to think of it as like I'm walking and I fell in the ditch. So I'm at the lowest part of the graph. So this is a minimum. Now they might even ask you, well, what is that minimum value? What is the lowest you go? Well, the lowest you go is -4. Y equals -4. It's always going to be Y because the Y is the one that's up and down. It's always going to be Y, and then that number, you're always going to get it from the Y value of your vertex. Okay? Then they're going to ask you, hey, what are the x-intercepts? What are those zeros? What are those roots? Remember that it's got all these different names. Zeros, roots, solutions. And all they want to know is just the x-intercepts. And what were they? Well, we have 2 of them. 2 roots, or 2 solutions. What were they? -1, -2, -3, 0, and 1, 0. And sometimes they'll write it like that, individually. Okay, so these are your roots, your zeros, okay, your x-intercepts, whatever you want to call them. And they'll write them individually, or they'll write them like this. I'm crossing the x-axis at -3, and I also cross it at 1. They'll kind of put those 2 numbers together. Okay? So it depends how they write it. What was the y-intercept? The y-intercept was down here. Let me see. Right there. Y-intercept. It was 0, -3. Okay. What is the domain? The domain's easy because it's always all real numbers. I have an arrow that points left and an arrow that points right, so all real numbers. What is the range? Well, range means Y, so I'm going to put a Y. My arrows are pointing up. Remember, it's upward, right? So that means I'm going to use a greater than or equal to. And again, I use the Y value of your vertex. Because your Y's are at -4, that's the lowest part, and everything else gets bigger. And those are it. That's all they can ask you. Okay? About a quadratic. So let's do another example. But I'll put that on another video so it's not too long.